this is called section 4-3, part B, okay? And this is, we're going to talk about the reciprocal quotient and Pythagorean identities. Not Pythagorean identities. And this is kind of setting you up for trig identities, which are like these puzzles, and maybe your parents or something told you nightmares about trig identities, but they're not so bad. They're kind of like little puzzles. But reciprocal quotient and Pythagorean identities. So already you know most of the reciprocal identities. So because I've talked about that already. Sine of theta is equal to 1 over cosecant theta, right? And vice versa. Cosecant theta is 1 over sine theta. Cosine theta is equal to what? 1 over what? Secant theta. And tangent theta is equal to 1 over cotangent theta. And those work backwards too. So cosecant theta, that's a CS theta. It's not CS theta, it's cosecant theta is equal to 1 over sine theta. And I'm not even going to write the other two, right? Because I could cross multiply and I get cosecant theta is 1 over sine theta. And I'll show you in a minute how we use some of those. Then we have the quotient identities, okay? Quotient. It's not QU, it's not QO. Sorry, I'm not a good speller. But quote QU, you have to have a U after Q, right? Quotient identities. And there's only 2 of those, really, identities. And one of them is that tangent of theta, this is an important one, is equal to sine theta over cosine theta. Okay, because tangent is y over x, right? So tangent of theta is also sine of theta over cosine theta. Okay? Cotangent of theta is, since cotangent and tangent are reciprocals, what do you think seems like my light is dying. Is it less bright than it should be? I don't know. No? Not. Okay. What do you think that cotangent of theta is? Cosine theta over sine. Is it cosecant over secant? You could say that maybe. What? It'd be 1 over. I don't know. I'd have to think about that. Okay? But those are your 2 basic quotient identities and your reciprocal identities. And then you have the Pythagorean identities. Okay? And Pythagorean identities just come, Pythagorean just come out of the unit circle, right? And if this is a point on the unit circle, x, y, and this is 1, okay, then if this is x and this is y, what's got to be true about, and this is a right triangle here, what's true about x? What would be true by the Pythagorean theorem? X squared plus y squared, right? X squared plus y squared equals 1. But when we're talking about trigonometry, x is just the cosine, right? Cosine squared of some angle theta plus the sine squared of some angle theta is equal to 1. And usually they write sine first and then cosine. Doesn't matter, okay? But this is the most basic Pythagorean identity. And if you go to your calculator, watch. This is kind of cool, okay? And doesn't even matter what mode you're in. Doesn't even matter what mode you're in. I could take any angle, okay? And I could go sine of, I'd have to go like this. I'd have to put it in parentheses. But if I did like sine of 57.3, close parentheses, and then close the second set of parentheses, and then I'm going to square that, okay? And plus cosine of 57, whoops, I need to put that whole thing in parentheses because I need to square the whole thing, not just the 57. I'm going to put that in parentheses, cosine of 57.3, close that parentheses, square it, okay? What do you think the answer is going to be? 1. Let's see if that's right. That's equal to 1. Amazing, huh? So any angle that I plug in there, it's going to always give you 1, okay? Because it's a point on the unit circle. Matt, can you please put your iPod away? Thank you. So that's how you do, that's Pythagorean identity. Now, there's 2 other Pythagorean identities which I would prefer that you would not memorize. You can memorize them, but it's really easy to figure out where they come from, okay? Divide everything by cosine. So if I take this Pythagorean identity and I divide everything by cosine squared, okay? Cosine squared, divide this one by cosine squared, divide this one by cosine squared, okay, theta. What's cosine squared over cosine squared? 1. This turns into 1. Okay? What do you think that sine squared divided by cosine squared is? What's sine over cosine? Tangent. Okay, so this is tangent squared. Okay? And 1 over cosine is what? Secant squared. There's your second Pythagorean identity. Okay? So I can just divide everything by cosine squared. I'll get my second one. So if you ever forget the other 2, derive them because it's easier. Because I can never remember them, so I derive them all. Okay? The next one is you divide everything by sine squared. Okay? So I'm going to take cosine squared theta plus sine squared theta. And like I said in the book, usually they have sine squared and then cosine doesn't matter. And I divide that by sine squared theta, and divide that by sine squared theta, and divide that by sine squared theta. What's cosine squared divided by sine squared? Cotangent squared, right? This becomes cotangent squared theta. What's sine over sine squared? What's anything squared over anything squared? 1. And what's 1 over sine equal to? Cosecant. Okay? And there's your third trig identity. Those are in your book. Okay? So you start with sine squared plus cosine squared equals 1. And then you can derive, this is number 2. This is number 3. Yeah, I don't care if you... But those are your 3 trig identities. This plus this equals this. And I could never really remember them, but I remember that one of them has tangent squared and a 1 on that side. And then I remember tangent goes to secant. And the other ones are both cos, right? So cotangent squared plus 1 equals cosecant squared. I always forget it. But the other thing is these things can be flopped around. So what would secant squared minus 1 be equal to? Tangent squared, right? And what would 1 minus sine squared be equal to? Cosine squared, okay? And so they combine these in different ways. And what would Did I ask you that already? What's secant squared minus tan squared? 1, okay? And cosecant squared minus cotangent squared is also equal to 1. So sometimes you'll see different permutations of those, okay? But so how are they used? For solving problems like this, okay? So they'll say, first, if tangent of theta, so use trig identities, so they'll say tangent of theta equals 3, and they'll say find, that's a semicolon. I think you're supposed to put a semicolon. I don't know. Find the cotangent of theta and the secant of theta using trig identities, okay? Well, cotangent of theta is really easy. What's a cotangent of theta? So that's 1 over tangent. So this one is just 1 over 3, right? That's easy. Yes? Now to find secant squared theta, probably I could just jump to this one. See it? Okay? So to find secant squared theta, I'm going to use this. I'm going to find secant theta using this trig identity, because there's no way to get directly from here to find secant unless you draw units, you draw a circle and you try to figure it out. So I'm gonna do it this way. So I'm going to say 1 plus, they give me tangent squared, right? Or they give me tangent, which is 3. 1 plus 3 squared equals secant squared theta. Okay? So what's 1 plus 3 squared? 10 equals secant squared theta. And so secant of theta equals plus or minus 10. We'll just say that in this case it's 10. Usually they'll say you're in the first quadrant or something like that, so there'll only be one answer. I'm sorry, square root of 10. Sorry, I was sleeping. That's square root of 10. Square root of 10. Okay? Is that easy enough? So you're using those trig identities to find various things. Now, they introduce you in this part to the idea of trig identities. And a trig identity, when you're proving a trig identity, is kind of like a trigonometric proof. So they'll say something like, show that, and these get really fun in a couple sections, okay? Show that cosine of theta times the secant of theta is equal to 1. Who can tell me how I would prove that? Pretty easy to prove. Go ahead, Ella.
You would change secant of theta to 1 over...
Sure, yep. So secant of theta can be rewritten as 1 over cosine theta, and then what goes away? Boom, boom, and you're done, equals 1, and you're done. Piece of cake? That's called a simple identity. And an identity is where you work with one side to get it to look like the other side. Okay, we'll get to some more complicated ones in the next section. Okay? This one is a little bit tricky. What if they said, show that secant theta plus tan theta, plus tan theta minus, or times secant theta minus tan theta is equal to 1. What do you think I do? If I see 2 distribute or FOIL, right? 2 first give you what? What's secant times secant? Secant squared. Oh, and by the way, when you're writing secant squared, write it like this, secant theta squared, because this means take theta squared and then take the secant of it, which is different than take the secant. So this and this are equivalent, okay? But if you forget your brackets, then it ain't right. All right? So this means this. So this is equal to secant squared. What happens to the tan theta secant theta minus tan theta secant theta?
They cancel out.
They disappear. What's tan times tan? Negative tan squared theta. And you want to show that that's equal to 1. So now I'm going to use one of those previous trig identities, which involves, if you go back a page, right? I probably want to use the one that has secants and tangents in it, like this one right here. So what's secant squared equal to? Secant squared? Secant squared is 1 plus tan squared theta. 1 plus tan squared theta. So I'm going to use that identity. Okay? And so secant squared is 1 plus tan squared theta. So I'm going to plug that in. I'm going to erase this because it's probably getting you confused. Okay? So secant squared is 1 plus tan squared theta, right? Minus tan squared theta, what do I get? What do I get? Tan squared theta, what's tan squared theta minus tan squared theta? 1. This and this cancel, right? Because it's this minus this. And you get 1 equals 1. And then you're done. Okay? Yes? Did I do something wrong again? Where did I get? I substituted, I used my trig identity that said secant squared is equal to 1 plus tangent squared. Yeah. So I have to use trig identities to prove something. Don't do this. Don't do this. Okay? Okay. How do you do this? What is it? How do you do this? Wait, what is it again? Sine of x. Sine of x. What was it? I have to think about it. Sine of x over n. Is that what? Sine of x over x is not equal to 6. Yeah, sine of x, don't do this, okay? This is a mathematical faux pas. You can cancel out the 2 ends, right? And you get 6, see? Okay, but no, it's a math joke. Don't do that. This is all right. 6. Okay, so that's kind of all we're going to learn. How about what time do we get out of this place? 6:58. So